A supercharger is a device that pressurizes the air supplied to an internal combustion engine, providing an increased amount of oxygen to the engine. This increased oxygen supply results in more efficient combustion and increased engine power output. Superchargers are typically powered by a belt that is connected to the engine's crankshaft, and they come in two main types: positive displacement and centrifugal. Positive displacement superchargers work by trapping a fixed amount of air and forcing it into the engine, while centrifugal superchargers use an impeller to compress incoming air. Superchargers are commonly used in high-performance engines, such as those found in racing cars and aircraft, but they can also be used in street cars to increase their power output. However, supercharging an engine can put additional stress on its components and may require modifications to the engine to ensure its reliability and longevity. A supercharger works by forcing more air into the engine than it would otherwise take in through normal atmospheric pressure. This additional air allows more fuel to be burned in each cycle, which produces more power. There are two main types of superchargers: positive displacement and centrifugal. Positive displacement superchargers work by using a mechanism to trap and compress air before delivering it to the engine. They provide a consistent and predictable boost in power across the engine's RPM range. Centrifugal superchargers, on the other hand, use a spinning impeller to compress incoming air. They produce a boost in power that increases as the engine RPMs rise. Both types of superchargers are powered by a belt that is connected to the engine's crankshaft. As the engine turns, the supercharger is spun and begins compressing air, which is then delivered to the engine's intake manifold. Supercharging an engine can provide significant increases in power output, but it also puts additional stress on the engine's components. As a result, it may be necessary to upgrade other parts of the engine, such as the fuel system, to ensure that it can handle the increased power. Additionally, supercharged engines typically require more frequent maintenance and tuning to ensure they are operating at peak performance. Parts of supercharger. The exact components of a supercharger can vary depending on the type and design of the supercharger, but there are several common parts that are found in most supercharger systems. Number 1. Compressor. This is the main component of the supercharger that compresses the incoming air and forces it into the engine. Number 2. Drive system. The drive system consists of a pulley or belt that connects the supercharger to the engine's crankshaft. As the engine turns, the supercharger is spun and compresses air, which is then delivered to the engine's intake manifold. Number 4. Intake manifold. This is the part of the engine that distributes air to the engine's cylinders. In a supercharged engine, the intake manifold is designed to handle the increased airflow and pressure produced by the supercharger. Number 5. Intercooler. Some supercharger systems include an intercooler, which is a heat exchanger that cools the compressed air before it enters the engine. This helps to increase the air density and improves the engine's performance. Number 6. Bypass valve. The bypass valve is a safety feature that allows excess air to bypass the supercharger when it is not needed. This prevents damage to the engine and supercharger from excessive pressure. Number 7. Supercharger oil. Many superchargers require oil to lubricate and cool their internal components. The oil is typically contained in a separate reservoir and circulated through the supercharger by a pump. These are some of the main components of a supercharger, but different supercharger systems can have additional parts or variations on these basic components.